Welcome back from an ad break. So now let's jump back in. So our second concept is our pure substances, whereby we'll be looking at compounds and elements. So pure substances can be classified as elements or compounds. So by definition, an element is a pure substance. Very important to remember, it's a pure substance that consists of only one type of atom. And it cannot be broken down into other substances even by chemical means. Whereas a compound, that's also a pure substance. So both elements and a compound are pure substances, but a compound is a pure substance that contains two or more elements that are chemically bonded in a fixed proportion or in a fixed ratio. So we also need to know that as much as elements are different in the periodic table, the compounds are also different. Now, each compound has a unique name. And then, for instance, we have this particular one here, CO, CO2, and SO3. All of these particular compounds, they have different names in as much as the elements are different from the periodic table. The first one is carbon monoxide, the second one is carbon dioxide, and then the last one is sulfur trioxide. So all of those are particular compounds that we have seen here. They each have their own unique identity, which is their name. Now, when we write the chemical formulae, when we write these formulas of these compounds, they always are a combination of the symbols of the elements in the compound. So the elements that are going to bond and form a compound, we are going to take those particular symbols of those elements, combine them, and form a compound. However, remember that they must be in a certain ratio, a fixed ratio for a particular compound. When we are looking again at that particular compound, NaCl, when the element of sodium and chlorine combine chemically to form that compound NaCl, which is sodium chloride. When they combine to form this sodium chloride, there's going to be a change in composition and a change in properties, meaning that the compound will have different properties as the elements that are making up that particular compound. For instance, we have that now our sodium, it is a soft metal, it is a soft gray metal found in group 1, and then our chlorine, it is a pale yellow poisonous gas found in group 7. So this is in group 1 and this is in group 7. Remember, elements in group 1 are called alkali metals, and elements in group 17, they are called halogens. And then these two elements, they have different properties. One is a metal, a gray soft metal, and the other one is a poisonous yellow gas. However, when they combine to form a compound, they are forming sodium chloride, which is a white solid. So this white solid is different from the metals which we're making it up. And then remember that the chlorine was a poisonous gas, but we are able to consume the compound that is made from that particular reaction, which is the table salt. So sodium chloride, we know it as the table salt that you consume on a daily basis when we cook. Now, when moving on to our next concept, whereby now we need to name these compounds, we have seen how they react, we have seen how they combine in a certain ratio to form something new. Now we need to be able to name these compounds. As we have seen, sodium chloride can be said it's a table salt. But then how about other compounds? Firstly, we need to know that there are two main groups of compounds. There's type 1 and type 2. So the first type is the compounds that contain both metals and non-metals. That's now between the left-hand side of the periodic table and the far right-hand side of the periodic table. So when those two combine, they are going to form the first type of the compounds. And then the second type would only be the ones only containing non-metals. So now only focusing on the far right-hand side of the periodic table. So now when those combine, they only form the second type of the compounds. So in order to be able to name these compounds, we are using this system, the IUPAC system of naming the compounds, which stands for International Union of Pure Applied Chemistry. However, the rules that are contained in the IUPAC system are very complex. For our purposes, we're only going to be naming the compounds that only have two elements in them. So to start, we're going to start with the type 1. That's now the compounds that contain a metal and a non-metal. Now these compounds, they have two-part names, whereby the first part is the name of the metal. So we have that particular compound, you need to start by naming the metal in that compound. So that's the first part. And then the second part, it is the name of the nonmetal found in that particular compound. However, that nonmetal must have the ending IDE. Remember, our nonmetals include oxygen, chlorine, iodine, bromine, and so forth and so forth. So whenever we have one of those nonmetals, for instance, oxygen, so we're going to name the metal plus that particular nonmetal, but then that nonmetal must change the ending to IDE. So oxygen is going to change to oxide, whereas chlorine is going to change to chloride, whereas bromine is going to change to bromide. So now it's going to be a combination between the metal and the nonmetal, but that the nonmetal needs to change the ending, we're just adding the IDE. For an example, NaCl, which is a combination of sodium and chlorine, whereby our sodium is our metal and our nonmetal is our chlorine. How do we name them? We start by naming the metal, and then the nonmetal, we just simply change the ending. As we have said, sodium chloride. Notice the ending there, IDE. So chlorine has changed to chloride. The second example, we have MgS, magnesium sulfide. The magnesium is our metal found on the left-hand side of the periodic table, the sulfur found on the right-hand side of the periodic table. So therefore, the sulfur is going to change the ending. You just need to add the IDE at the end of sulfur, and then it's going to be sulfide. So then our compound is going to be magnesium sulfide, because again, it's a combination of the metal, nonmetal. Start with the metal, and with the nonmetal, change the ending IDE. Then the type 2 now, the second type of the compounds, or the ones that only contain the nonmetals. Now also these ones, they have two-part names, whereby now we are going to name them as follows. We're going to follow certain rules to name these particular compounds. Rule number 1. So the name of the element further to the left in the periodic table comes first. So we have the nonmetals. We know that the nonmetals are located on the right-hand side of the periodic table. But within the right-hand side, we have elements that are a bit to the left of the periodic table. And then we're going to name that particular compound starting with that particular element that is further to the left. Then you're going to be followed by the name of an element further to the right of the periodic table. So it's left, right, always. And then now, the name of the second element, remember that both of them, they are nonmetals, but the name of the second element, which is found on the right-hand side of the periodic table, needs to have the suffix IDE. Now the suffix, it is that ending, that letters or the name that we add at the end of the word. So now, the suffix is going to replace the ending of the name. For instance, oxygen, it is going to become oxide again. Fluorine becomes fluoride. Chlorine becomes chloride. Nitrogen becomes nitride. Remember, these ones will be towards the right-hand side of the periodic table. Then the ones before the left-hand side, we name them in full. Now, rule number 2. When two or more compounds have different numbers of the same elements, for instance, we have CO and CO2. These two compounds, they have the same elements, but then the only difference is just the ratio or the number. In this one, we only have one oxygen, whereas in the other one, we have two oxygens, but the elements are the same, just a difference in the numbers. So how do we then name these particular compounds? We add a prefix. Prefix is the name or the word that we add before the name. Prefix is before, suffix is at the end of the name. So now we are doing this to avoid confusion, because these two, they have exactly the same particular elements, just different numbers. So we wouldn't be able to name them. So to minimize the confusion, we are going to add the prefixes. So now, what are we going to add? If the number of atoms is 1, we're going to add mono. We're going to add 2 for di, tri for 3, tetra for 4, and then penta for 5. So in our current grade, we're only going to be ending up to 5. Whereas if you move on to the FET phase, you're going to be going all the way to 9 or even to 10. But for us, we're going to stop here at 5. What we also need to note is that a prefix is not used with two nonmetals when there's only one atom of the first element. For instance, we have an example here, CO2. we are not going to say this is a monocarbon dioxide because the first one only has one atom. So it's going to be just carbon dioxide. Remember the di, it is for the 2. We have 2 atoms of oxygen, so it's going to be carbon dioxide. Now, our next rule, which is a bit easier, in this particular one, we have seen that in many instances at home, we have certain compounds that we name for other people to be able to know what we're talking about. For instance, you will never ask your mother to give you a glass of H2O, but you will say water. And your mother will never send you to the shop to go buy NH3, but then they will say go buy handy. But then you know that they mean ammonia or NH3. And then you also know that we also have methane in our everyday lives, but then we never refer to them as CH4 or methane. We refer to such compounds with their common names that we normally use on a daily basis. So we have seen how to name the compounds. We have seen that we have 2 types of compounds, the ones that only contain the metals and the non-metals. We also have the ones that contain only just the non-metals, and those ones, they can be named using the 3 different rules. I sure hope you know how to name them. You can go back and try to name all of these particular compounds that you have seen and all the others that you might see in your textbook and whenever you're doing this particular topic in class. So with that said, I hope you had as much fun as I did. I'll see you next time. Bye.